Good day. I welcome you all at the lecture on analysis of three-hinged arch of subject structure analysis 1. The subject code is CEPC503 and the related model number is 2. Myself Sandeepan Saha, Assistant Professor for the Department of Civil Engineering of Greater Kolkata College of Engineering and Management under JIS Group. Let us first proceed to have a look on the topics that we are going to cover in this lecture. And those are as follows, that is basic concepts of three-hinged arch, various components of a three-hinged arch, analysis of arch and numerical example. Beams transfer the applied load to end supports by bending and shear action. In this process, either one or 2 points at a particular section is subjected to maximum stress. The material in most of the portion is under stress and hence underutilized. The horizontal distance from one support to another support is called the span. For larger spans, beams are very uneconomical and many a time the self-weight of the beams contributes to the stress in such large portions that it is difficult to design beams for larger spans. For large spans like bridges, arches are provided instead of beams. Arches are nothing but carved beams that transfers loads to their plane. Arches transfer loads to abutments at springing points. Hinges may be provided at these points. The topmost point is called crown, which sometimes has a hinge, and it is then called a three-hinged arch. The height of the crown above the support level is called rise. Because of the carved nature of the arches, they give rise to horizontal forces also. Abutments are designed for horizontal forces. Any section in the arch will be subjected to normal thrust, radial shear, and bending moment. However, the bending moment is considerably less compared to a beam of the same span. Thus, loads get transferred partly by axial compression and partly by flexion. In axial compression, each and every particle of the cross-section of the structure is subjected to stress equal. Hence, the material is utilized fully. Reduction in the bending moment results in smaller sections for the arch compared to the section required to the beams to transfer the same load. This is a picture of an arch bridge. These are the arches. As you can see, these are the arches that are provided in the bridge, and over the arches there is the roadway. This is a typical picture of an arch bridge. Where this is the abutment. So this is the abutment, and the springings are here, and sometimes at the topmost point, that is at here, and this point is called crown, and the height of the crown from the support level, that is from here. So the height of the crown from the support level is called the rise, and this is the span of this arch from here to here. And one thing to be remembered specifically, that this crown, this is the crown, so this is the topmost point of the arch, that is the arch is here. This is the arch, this is the arch. So the arch starts from here and ends at here. So from here to here, the curved red color drawing is the arch. In our current study, we will be analyzing three-hinged arch. that is here. And this is a typical picture of a 3-hinge arch. As you can see, one hinge is at A, one hinge is at the topmost point, that is at the crown point C, and the third hinge is at the support point B. Normally, the 3-hinge arch is of two types, that is, one is circular arch and a parabolic arch. In case of the circular arch, from the properties of circle, we have a working equation, that is L by 2 into L by 2 equals to H into 2R minus H, and this equation can be used in analyzing the circular arch, where L is the span of the arch. As you can see, L is the span of the arch, H is the height of the crown from the central position, that is here, that is H is the height of the crown, that is the crown is the topmost point of the arc, and R is the radius of the circular arch. So this is the radius of the circular arch. L equals to the span of arch, that is here, and H is the height of crown, that is this. Now, in case of a parabolic arch, we have a working equation, that is y equals to 4hx by L square into L minus x, and this equation can be used for analyzing a parabolic arch. Let us take a XX section at a certain point on the arch. If a certain point on the arch is D and the section XX goes through this section, this point, so the XX section goes through D point, then the distance of XX section from the left hand support A is expressed as x, that is small x, and the height of point D with respect to the support level, that is, we are talking about this height. We denote this height as y. So y is the height of the point D from the support level. So y is the height of the point D from support level, and small x is the distance of the section XX which goes to the point D, and x is the distance of the section XX from the left hand support A. So we can calculate y from this equation, where again I am saying L is the span of the arch and h, that is small h, is the height of the crown from the support level of the arch. So h is the height of the crown from the support level. So For analyzing an arch, we need to calculate the normal thrust, that is this one, and the radial shear, this one, at any point on an arch. Here we have taken an arbitrary point D, and with respect to point D, that is at point D, we will calculate the normal thrust N and radial shear Q. As per the formula, N equals to V sin theta plus H cos theta, and Q equals to, that is the radial shear, equals to V cos theta minus H sin theta, where V is the vertical shear at point D. Again I am reminding, N is the normal thrust at point D, and Q radial shear, that is Q is the radial shear at point D. And theta is the, theta means this, 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 this. So theta is the slope at D. So from here we get, so theta is the slope at point D. So let us do a problem on a 3-hinge parabolic arch. The problem is this one. This is the problem. So the problem says that a 3-hinge arch of span 20 meter and rise 4 meter carries a uniformly distributed load of 20 kN per meter on the left half of the span, that is here. So in this problem we have to find out the maximum bending moment for the arch. So this is a 3-hinge arch, as the hinges are situated at A, C and P, and this is the span of the arch, that is from here to here is 20 meter, and the rise at the central, that is the maximum rise at the central point position of the arch, is 4 meter. So now we have to solve this problem, and don't forget that this 20 kN per meter uniformly distributed load is acting at the left half portion of the span, that is here. So in order to solve this problem, first we need to calculate the vertical reactions at A and B, that is we have to calculate the VA and VB. In order to do so, let us take moment above point A. We have summation of moment equals to 0. So we have moment 20 into 10 into 5, that is 10 by 2, minus VB into 20. Solving this equation, we get Vb as 50 kilonewton. So V equals to 150 kilonewton. So sign convention for this calculation, that is this calculation, we have clockwise moment as positive and anti-clockwise moment as negative. Now let's calculate the horizontal thrust, that is H. So taking moment about point C, we have that summation of moment equals to 0, as this is a hinge support. So we have here H into 4, that is when we are taking moments about point C, the first moment we counter is the moment caused due to the horizontal thrust, that is H, and the distance between H and point C is 4 meters. So the moment is H into 4, and it is causing the clockwise moment. So this is positive, and next is the force is Vb. So moment generated due to Vb is in the anti-clockwise direction. So we are taking this as negative. So the moment caused by the force Vb is Vb into 10 meter, as the distance between point C and force Vb is 10 meter. So calculating this, we get H equals to 125 kilonewton. So from calculation we have V equals to 150 kilonewton and Vb equals to 50 kilonewton and H equals to 125 kilonewton. Now let's take a section which is situated. Now we are taking a section XX, which is situated at X distance from point A, that is from the left hand support, and its height is Y. So from the property of parabola, we have Y equals to 4h by L square into x by minus into L minus x, where h equals to 4 meter, that is the central rise, and L is the total span of the arch. So putting the value of L and h, that is h equals to 4 meter and L equals to 20 meter, we get 4 into 4 by 20 square into x into L, that is 20 meter minus x. We get y equals to 1 by 25 into x into 20 minus x. So now cal calculate bending moment about the section XX. So we have bending moment about section XX, that is mx equals to 150 into x minus 20, that is this force, 20 into x into x by 2 minus 125, that means this force, 125 into y, as the distance between the horizontal thrust and the section XX is y. So we get this equation, and you have already calculated the value of y. So putting the value of y at this equation, we get 150 into x minus 10x squared minus 125 into 1 by 25 into x into 20 minus x. So we have this equation. Now upon further calculation, we get mx equals to 150x minus 10x squared minus 100x plus 5x squared. Upon further simplifying, we get 50x minus 5x squared. So mx, that is moment about section xx, becomes 50x minus 5x squared. We have 5x into 10 minus x. Mx equals to 5x into 10 minus x. Now, for the condition of maximum bending moment, for the condition of maximum bending moment, differentiating mx with respect to x, we get dmx by dx equals to 0. So we get, after Differentiating the value of mx, we get 50 minus 10x equals to 0. And upon further simplifying, we have that we get x equals to 5 meter from this equation. X equals to 5 meter means that the maximum bending moment occurs at a distance of 5 meter from the left hand support, that is from here. So putting the value of x equals to 5 meter at this equation, we get maximum bending moment, that is m max equals to 5 into 5 into 10 minus 5. So the maximum bending moment is 125 kilonewton meter, which occurs at a distance of 5 meter from the left hand support A, that is from here. Thank you.